Hello, algebra students, Mr. Lawrence here, and we're going to be talking about solving inequalities, and we're going to be presenting our answers in solution sets and also on number lines. And let's get right down to it. Number one, why don't you pause this and see if you can solve this on your own, okay? And then also with number two, go ahead and pause them. See what you can do. I know you guys understand most of this stuff pretty well. All right. If you're still watching at this point, I'm assuming that you've already tried it on your own. I'm going to do this first one by distributing. I really don't want to do it by distributing, but I know most of you are going to do it that way. So we're going to get 6x minus 30, and that's going to be greater than or equal to 30. And then we're going to treat this like a two-step equation the rest of the time. And so we're going to add 30 to both sides. I'm going to add 30 to both sides. And 6x is going to be greater than or equal to 60. And we're going to divide by 6 and divide by 6. And we're going to get x is greater than or equal to 10. Okay, so there's a solution set. There's a solution in words. And a solution set would be x is any real number such that x is greater than or equal to 10, and it didn't work out very clearly. Hopefully you're taking some notes there. Hopefully you got that. Then of course on a number line, let me draw a number line here. All right, and I'm going to put a 10 there, right? Maybe I'll show a 0, maybe I'll show a 12. Now remember, to figure out which way to shade, I'm going to fill some number in for x, a number that makes this true. So I put 12 on my number line. I think I'm going to fill that in. Sorry, having a little trouble with the mouse here. So I'm going to put 12 in. Is it true? It sure is. So do I need an open point or a closed point here at 10? 10 is the, keep number. Well, it's a closed point, right? Remember, because it says equals 10, the number I put in there could be 10. Could be 11, could be 11 and a half, 11 and 3/4, could be 1,655, any number that's 10 or greater. And so I will shade this way. Okay, now I mentioned that this isn't the way I want to do it. I wanted to do it this way. Oh, that's right, the eraser's not working on this, on the pen that is. Okay, I'm going to go ahead and leave that picture there. But I'm going to solve it the other way just because I want to, and it's good to see different ideas on how to solve inequalities or equations for that matter. So I see 6 times the quantity of x minus 5, so 6 is a factor of the left-hand side, right? There's two factors. There's 6 and then there's x times 5. X minus 5, excuse me. The factors of 30. I know 6 is a factor of 30, so I'm going to think about 30 as the product of 6 and 5. Oops, sorry about that. Hold on one second. I forgot to close my email out. Let me quit it. That way nothing pops up. Okay. So I'm going to have some more problems with my mouse. And I'm going to divide by 6 here. And then remember, I'm thinking about 30 as 5 times 6. Well, since there's a 5 and a 6, the 6's can cancel. And of course, these 6's will cancel. And my new equation or inequality will be x minus 5, which is greater than or equal to 5. And then I'll add 5 to both sides. And I will get x is greater than or equal to 10. Okay, notice it's the same thing. I'm not going to go through the whole solution set and all that. It is the same thing. All right, number 2. Now this one might give some of you some trouble. Some of you are going to want to add a 5 to this problem, but I don't believe there is a 5 in here. I think there's a negative 5/3. See that negative 5/3 right there? But there's not a 5 per se. What's really bothering you is this fraction. Well, let's get rid of it. Let's get rid of that denominator of a 3. I'm going to multiply by 3 over 1, and on the right-hand side, I'm going to multiply by 3. So when I do that, these 3's will cancel. The left-hand side will leave me with 2x minus 5. And that'll be greater than 45. Now it's a two-step inequality, and I'll add 5 to both sides. And I'll get 2x greater than 50. I'll divide by 2. divide by 2, and I'll get x is greater than 25. All right, so my solution set will look like this. X is any real number such that x is greater than 25. All right, there we go. And when I draw a number line, okay, I've got to show 25 on my number line. Okay, I'm going to show 25. Maybe I'll show 30, and maybe I'll show 10. All right, is there going to be an open point or a closed point at 25? Well, it doesn't say equals, does it? So since it doesn't say equals, I'll use an open point. Now again, I'm going to test it. I'm going to put a number in there that makes it true. Okay, or I guess I could counter test it. I could put a number that makes it false and then not shade that way. That doesn't make as much sense to me. So I'm going to try to make this true, and I'm going to put 30 in. 30 is greater than 25. It is a true statement, so I shade in the direction of the 30. Okay, always test it. Don't just say, well, I'm going to shade this way. Always test it. All right, let's take a look at this one here. JoJo was asked to solve the following inequality. 6x plus 12 is less than 3x plus 6. Her work is shown below. So here we have this first equation, and it looks like she undistributed, right? She pulled that 6 out. We're going to call that a big F word later on. That's going to be called factoring, but for right now, we're just going to call it undistributing. She recognized it was a common factor, and she pulled it out. Okay, then on the right-hand side, it looks like she undistributed again. And then she thought, I'm going to divide by x plus 2 on both sides, and I guess that's shown below. I don't know why I'm rewriting it. And she came up with the inequality. Man, this mouse is driving me nuts. She came up with the inequality that, because here on this step, right, these would cancel, right, this x plus 2 and x plus 2, right? Okay, so she came up with 6 is less than 3, which is a false statement. And she remembered in class that, Mr. Lawrence said when you get a false statement, that means there's no solution. Okay, but there's something very, very wrong with her work. Something terribly wrong. What do you think is wrong? What's that, Lauren? Well, you got to be careful with fractions, Lauren, because there's a number we're never, ever, ever allowed to divide by. Does anybody know? Let's see, can I divide by 1? Yeah, if I divide by 1, it's 5. Can I divide by bigger numbers like 10? Yeah, sure I can. Hold on a second. There it goes. 5 divided by 10 is 1/2, right? Can I divide by negatives? Sure, 5 divided by -5 is -1. Okay, so it's really pretty easy, but sometimes kids overlook this. They don't think of it as a number. There's one number on the number line that I am never ever allowed to divide by. It's not because you're not smart enough, you don't know how to do it yet. It's because there is no definition for it. I can't divide by this number. Einstein couldn't divide by this number. Nobody can. Okay, that number is 0. You cannot divide by 0. 5 divided by 0 is called undefined. So you tell me that is undefined. You can never divide by 0. Did you write that down? Never, ever, ever divide by 0. It's undefined. The problem with dividing by this x plus 2 quantity is that if x equals -2, which it might, what happens to our division? Our denominator, we end up dividing by 0. You are never allowed to divide by 0. So here's what I want you to do. I want you to take that original inequality, which is what? 6x plus 12, and that's going to be less than 3x plus 6, right? Okay, so now I want you to take one of the approaches I showed in class. We don't like to have variables on both sides, so let's subtract one of the variables. I prefer to subtract the variable with the smaller coefficient, right? I've told you that. Okay, and so we're going to get 3x plus 12, which is less than 6. And then we're going to treat this like a two-step equation the rest of the way. We're going to subtract 12, And we're going to get 3x is less than negative 6. And we're going to divide by 3. Wow, this thing's really messing up. Wish I had a pause button. I could fix it and then come back to the video. So x is going to be less than negative 2. So my solution set is not no solution. There actually are numbers that make it true. In fact, if we had thought of it, we could have tested with some numbers. We could have put in, say, a negative 3 in for x, and we would come up with a true statement, okay? If you want, ask me about that in class tomorrow, and we'll demonstrate it. Now, the solution set would be x is any real number such that x is less than negative 2. All right? So, on a number line, we're going to show negative 2 on there. I'll show 0, and maybe I should show like negative 4. And there is an open point at negative 2. Why is that, Emily? Because it's not equal to, right? Yeah, of course. So now I need to fill in this blank is less than negative 2. Let's go with negative 10 is less than negative 2. And negative 10 would be to the left of negative 2 on a number line. And so there we go. So what we're showing on the number line is all the numbers in the real number system. And remember, there are more numbers on the number line than there are stars in all the universe. Okay? This picture is showing me every possible solution to the inequality 6x plus 12 is less than 3x plus 6. Okay, now there's one thing you got to be careful of, and we're going to show it here. Okay, let me see here. Having some more trouble. All right, check this out. We're going to check out this negative 5x plus 15. Now, some of you are going to do it, and you're going to get the wrong answer. Okay, I want you to pause the video and just do the negative 5x plus 15 right now. Okay, don't watch the video until you've tried it. Jared, have you tried it? All right, good man. Now, some of you, here comes my solution. Some of you are going to divide by negative 5, and you're going to try to tell me that x is going to be less than negative 3. Okay, now I'm going to test it. All right, I'm going to test it. Name a number less than negative 3. What's that, Boyana? Yeah, negative 5 is less than negative 3. That's absolutely true. I don't disagree with you. But what happens when I put a number like negative 5 in for x? Well, let's see here. Negative 5 times negative 5, and that's going to be less than 15. And negative 5 times negative 5 is 25. And 25 is not less than 15. No, it's not. What happened? What are you doing wrong? Well, there's something you may have heard, but it doesn't stick. So I'm going to have you think about the problem differently, and then I'll show you a shortcut way to do it. Oh my goodness, this mouse is possessed. Look at this thing. It's going all over the place. Okay. Here's what I want you to do. I want you right now to add 5x to both sides. Why? Because I don't want that coefficient to be negative. All right, so I'm going to add 5x to both sides. When I do that, I don't just say there's nothing over there. There's 0 over there. There's no other number, so I have to show the 0. And then I'm going to get 15 plus 5x. Now, I'm going to subtract 15 from both sides because I'm just following, my steps for solving a two-step inequality, very much like solving a two-step equation. And I'm going to get 5x. Negative 15 is less than 5x. And then I'm going to divide by 5. And I'm going to divide by 5. And I'm going to get a negative 3. That sounds familiar, right? Negative 3. And that's less than x. Now, if you remember the other solution, when we did it the other way, where it didn't work out, we ended up with x is less than negative 3. Are they the same solution? No, of course not. This one in black says x is less than negative 3. And so we plugged in negative 5 and we got a false statement. But let's pick a number that negative 3 is less than. Let's pick positive 5. I think you all agree that negative 3 is less than positive 5. Let's plug positive 5 in there. negative 5 times 5 is less than 15. Negative 5 times 5 is negative 25, and that's less than 15. And that's a true statement, isn't it? So why did it work out this way, but it didn't work out the other way? Well, the shortcut of it is, I just showed you the long cut. That's why we need to have a positive variable, okay? But the shortcut is, when you, positive coefficient on my variable, excuse me. When you divide or multiply by a negative, do you write this down? It's a very important rule. Should you get this? When you divide or multiply by a negative, Chandler, you got that? When you multiply or divide by a negative, the inequality changes direction. Yeah, I'm going to divide by negative 5, right? Negative 5. X is going to be greater than negative 3. And believe it or not, these say the same thing. No, they do not. Mr. Lawrence, you're lying to the students again. Actually, I'm sitting at my kitchen table, but that's beside the point. All right. We got the other one was negative 3 is less than x. Okay. These are the same thing. X is greater than negative 3 or negative 3 is less than x. They mean the same thing. If you don't believe me, fill them in. Fill them in. Put a number in here. How about 5 is greater than negative 3? Does it work over here? Negative 3 is less than 5? Sure it does. It doesn't matter which way it's presented. What you have to remember is that when you multiply or divide by a negative, when you multiply or divide by a negative, when you multiply or divide by a negative, the inequality changes direction. Okay? That less than becomes a greater than. Now, of course, the solution set would be x is any real number such that x is greater than negative 3. On a graph, number line graph, we're going to have that. We're going to have negative 3. Maybe I'll show 0. And I'll show a negative 5. Have to show a closed point. No, that's wrong. An open point, because it's not equal to, right? So an open point. And we said 5 was greater than negative 3, so I'm going to shade in the direction of 5. So I'll be shading this way. All right. Go ahead and try this other one here. I don't know if I gave a number. We'll give it number 5, because I think it's the 5th problem we've done. Try that one on your own. Okay, go ahead and pause the video. See what you come up with. All right, so here comes my solution. I'm going to subtract 3 from both sides. Right? And so I'm going to get the negative x over 2, which is greater than or equal to 1. And now to get rid of that 2, it's a division, right? It's being divided. I'm going to multiply. I'm not going to multiply by 2, though. Anybody know what I'm going to multiply by? Sorry, I started to write the answer there. I shouldn't have done that. I asked you. What's that, Lainey? That's right, Lainey. We're not going to multiply by 2. We're going to multiply by negative 2. Right, by negative 2. So I'm going to multiply by negative 2 over 1 and by negative 2. All right, the 2's will cancel, 1 to 1, and then the negatives will cancel. And x will be greater than or equal to 1 times negative 2 is negative 2. Okay, now I can check it, pick a number greater than negative 2. Let's go with positive 4. If I put positive 4 in here, I'm going to get 3 minus 4 over 2. And I'm going to get 3 minus 2, which is 1. Wait, what's wrong? It didn't work. What didn't I do? Oh, Mr. Lawrence, you forgot. You forgot. When you multiply or divide by a negative, you have to flip the inequality. You see why it's so important to check the work? Oh my gosh, I got to get this video over with because the mouse is taking over. I better go get an exorcist to get rid of this thing. X over 2. And then Lainey said I got to multiply by negative 2, right? Okay, so I'm going to multiply by negative 2 over 1. So nothing there is going to change. And so I'll get a negative 2 here. The 2's will cancel, the negatives will cancel, I'll be left with an x. But the greater than or equal to switches to a less than or equal to. All right, so my solution set is x is any real number such that x is less than or equal to 2. And now if I test it, I pick a number less than 2, like for example, 0. 3. Hello, James. Hello, would you like to say hello?
Hi!
Oh, there's a James greeting for you, ladies and gentlemen. All right, we'll have 3 minus 0 is greater than... Did I screw up again? Ladies and gentlemen. What am I doing wrong? I don't see my mistake. Silly me. Look at my solution set, ladies and gentlemen. I'm having some brain farts here. Don't visualize that. It's kind of gross. Okay. It's negative 2, silly me. I need a number that's less than or equal to negative 2. So 0 won't work. Oh my goodness. All right, one more try, and then I got to call it a night because I'm going to screw you guys up pretty bad. So let's check this out here. Last chance at a check. All right, let's go with 3 minus negative 2 over 2. Okay, the two negatives will cancel out. 2 divided by 2 turns into 1. And I end up with 3 plus 1, and that's greater than or equal to 4. Now, Derek's paying attention. So, Mr. Lawrence, I thought you said not to test with 2 or negative 2 or the number there. Yeah, you're right, Derek. So let's test with another number that's less than negative 2. Let's test with negative 10. So we're going to do 3 minus negative 10 divided by 2, and those the negatives cancel. 10 divided by 2 is 5. 3 plus 5 is 8. And 8 is greater than or equal to 4. And finally, my check works, and I didn't make any mistakes. Thank you, everybody. Have a good night. I'm going to crawl under the covers so that I don't make any more mistakes.
Bye!